All right, question number 18. We have a 10-kilogram box being pushed by a girl across a carpeted floor and it experiences a friction force equal to 60 newtons. So let's draw a free body diagram. We have Fn, we have Fa, and we have a friction force going to the left. Everything balances. Now, I saw a lot of work skipped. For full credit, I need to see the following. I need to see that you are clear on the fact that the vertical forces balance. So that means Fn balances Fg. That's true, but it's not helpful. And then I need you to set up a balanced force equation for the horizontal forces. So Fa is the unknown, 60 is the force that the girl applies, and so I actually need to see this entire process here. Okay, so show work or 0 credit. Okay, now it says, suppose she pushes with a force of 90 newtons, but the friction remains 60 newtons. We're going to draw a new free body diagram and determine the acceleration. So we have the normal, we have the weight. Those still balance vertically. But now let's look at the horizontal forces. We have the applied pushing force, and we have a friction force that doesn't balance. So now we have Fa minus friction equals m times a because they are unbalanced. You have to set up that horizontal equation. I need to see this. You must show this. So we're going to have 90 minus 60 equals 10 times a. That's going to give us 30 equals 10 times a. And so that gives us a is 3 meters per second squared. Awesome. Next, we wanted to determine the speed of the box after 3 seconds, assuming the acceleration is what we found in part B. So we're going to assume that it starts from rest. Okay, so v equals at plus u. V equals 3 from part B times the 3 seconds plus 0, which is 9 meters per second. Now, the girl lets go of the box, but the friction force still acts. We want to determine the new acceleration of the box and figure out the time it takes the box to come to rest. So we've got the normal force, and we've got the weight force. Those stay the same, but now we only have a friction force acting backwards. And since it acts to the left, we're going to say that negative F equals m times a. So that's negative 60, because that's from up here, equals 10 times a. So our new a is negative 6 meters per second squared. And we want to know the time it takes the box to stop. So that's going to be v equals at plus u. Let's be clear, it's going to stop. So that means 0 is the final speed. Negative 6 is the acceleration times the time, plus u is in fact the 9 meters per second that we got in part C, because that's the speed it was going at once the pushing force stopped. So when we actually isolate this, we're going to get a time of 1.5 seconds. So that actually wraps up our practice test. I'm going to go ahead a little bit later and do a video for the extra credit. And I'm going to actually have that worked out a little bit later too. I just want to get the bulk of the exam uploaded right now.